Hello dear students, welcome back to physics online session. Today we will be solving some numericals on moving charges and magnetism here. Some neat applications related to moving charges and magnetism. So just I will read out the question here. A particle having a charge of 100 microcoulomb, and charge particle is there, magnitude of that charge is 100 microcoulomb. So Q I can take it as 100 means 10 to the power of 2. 100 micro means 10 to the power of minus 6. So magnitude of the charge, so 10 to the power of minus 4 coulomb here. A particle having a charge of 100 microcoulomb and mass of 10 milligram. What is the mass of that charge particle here? 10 milligram. First I can take 10 into 10 to the power of minus 3 gram. Milligram to gram I can convert. From that gram to kg I will take. Or m is equal to 10 to the power of minus 2 gram, or I can consider that minus 2. So into 10 to the power of minus 3 kg, or directly I can consider here 10 to the power of minus 5 kg. What is the mass of the charge particle here? 10 to the power of minus 5 kg. Then is projected in a uniform magnetic field of 25 Tesla. It is projected means the charge particle is projected in a uniform magnetic field. Its magnitude is 25 Tesla with a speed of 10 meter per second. What is the speed of the charge particle? Speed of the charge particle is 10 meter per second here, right? Speed of the charge particle is 10 meter per second. The velocity is perpendicular, or speed is perpendicular to the magnetic field, means theta value is 90 degree. The radius of circular path and that time period of revolutions are. What are the quantity I need to find out here? Radius and time period here. Okay. In order to find out that radius, we are having that formula. R is equal to m into v divided by q into b. Mass is 10 to the power of minus 5 kg. Velocity is 10 here, and magnitude of the charge, so that is 10 to the power of minus 4. Magnetic field value is 25 here. R is equal to 10 to the power of minus 5 into 10 to the power of 1. 10 to the power of minus 4 divided by 10 to the power of minus 4 into 25. 1 by 25 means, so that is 0.04 meter here. What is our answer? 0.04 meter, or I can take that 4 into 10 to the power of minus 2 meter, or r is equal to 4 centimeter. What is the radius? I get it here. Radius is 4 centimeter. Then what about its time period? What is the connecting formula here? Time period is equal to what? Distance divided by velocity. So distance is circumference. So just 2 pi by v into r, where r is nothing but m into v divided by q into b. So 2 pi m divided by q into b. So this is the direct formula we are having. Just fill the value. Mass is 10 to the power of minus 5 divided by 10 to the power of minus 4 into 25. So time period is equal to, look at here, 3 1s are 3 8s are. So I don't want exact, means rough calculation I will do here. 2 4s, 1 by 4. So that is 0.25 into 10 to the power of, here minus 4 is there in denominator, sorry, here minus 5 denominator plus 4. So that is 10 to the power of minus 1, or 25 into 10 to the power of minus 3 second here, or 25 millisecond I can consider. This is the time period of revolution of the charge particle. We'll look at next one. We'll go for next one. Cyclotron. A cyclotron in which protons are accelerated has a flux density. Flux density means that is magnetic flux. In cyclotron, A cyclotron in which protons are accelerated has a flux density of 1.57 Tesla. Variation of frequency of the electron is. Here they mention magnetic field strength is 1.57 Tesla. What is that strength of the magnetic field here? 1.57 Tesla. And the variation of frequency is, so which thing I need to find out here? Frequency value. So frequency value I want to find out. Frequency is nothing but 1 by time taken. Just I will take that equation. So that is Q into B divided by 2 pi m. Right. Charge on the proton 1.6 into 10 to the power of minus 19. Here magnetic field is 1.57 they mention. 2 into mass of the proton, that is 1.67 into, this is the standard value, into 10 to the power of minus 27, whereas mass of the electron is 9.1 into 10 to the power of minus 31. Okay, into pi term 3.142, right? 1.5 divided by 2, and here I can take 1.6 is nothing but 16 into 10 to the power of minus 20. Here 8 you will get, or otherwise leave that one. This 1.6 term will getting cancel out here, right? If these terms are getting cancel out means 1 divide 1 means 1 into 10 to the power of minus 20 divided by 4 into 10 to the power of minus 27. Here frequency is equal to 1 by 4 means 0.25 into 10 to the power of minus 20 plus of 27, 10 to the power of 7 here. So 0.25 into 10 to the power of, sorry, here 19 minus 19. So this is 8, and frequency is 2.5 into 10 to the power of 7 Hertz. What about the frequency here? 1.6 only I consider. These terms are getting cancelled here. What about the frequency here? Frequency is equal to 2.5 into 10 to the power of 7 Hertz. We'll look at, okay. So we'll look at next one. A cyclotron adjusted to give a proton beam magnetic induction of 0.15 Weber per meter square. It is the another SI unit of magnetic field here. What's the value they given? In case of cyclotron, strength of the magnetic field is 0.15 Weber per meter square, or 1.5 into 10 to the power of minus 1 Weber per meter square here, and the external radius is 1.5 meter. Radius of that circular path is 1.5 meter. The energy of emergent proton in mega electron volt will be. I want to find out that energy. That energy is nothing but kinetic energy of the proton in mega electron volt here. For example, in case of cyclotron, what is the equation for maximum kinetic energy of the charged particle? Maximum kinetic energy is equal to Q square B square R square divided by 2m here. I want to find out that kinetic energy, right? Magnitude of the charge 1.6 into 10 to the power of minus 19 whole square. Strength of the magnetic field is 1.5 into 10 to the power of minus 1 whole square, and radius is 1.5 whole square here. In denominator 2 into charge means mass of the proton 1.67 into 10 to the power of minus 27. Here 1.67 term, here one term will get cancelled out. Kinetic energy is equal to 1.6 into 10 to the power of, okay, minus of here 38 I can consider into 1.5 into 1.5. What's that answer? 1.5 into 1.5, that is 2.25 into 10 to the power of minus 2. Here also 1.5, 2.25 divided by 2 I can consider, or I can consider this one is 16 here, okay, into 10 to the power of minus 27 I can consider. 8 here, kinetic energy is equal to 8 into 2.25 into 2.25, so that is 5. 10 to the power of minus 41 plus of 27, so that is kinetic energy is equal to 40 into 10 to the power of minus 41 plus 27, that is 10 to the power of minus 14 joules. Look at here, I got that energy in terms of joules here. Now they ask that energy in terms of mega electron volt. How to convert that energy from that joules to mega electron volt in case of that dual nature of matter and radiation, already you know, and in basic in first PUC also you know the thing. How to convert that energy from that joules to that mega electron volt or electron volt, I will convert first. So that is divide by 1.6 into 10 to the power of minus 19. How to convert that energy from that joules to that electron volt here? In order to convert that energy from joules to electron volt, make that divide by 1.6 into 10 to the power of minus 19 here, right? Or kinetic energy is equal to, or you can take this one as 16 into 10 to the power of minus 20. So that is 5 by 2 here. So 5 by 2 means that is 2.5 into 10 to the power of minus 14 plus of 20 here. So look at here, kinetic energy is equal to 2.5 into 10 to the power of minus 14 plus 20, 10 to the power of 6 electron volt here. 10 to the power of 6 means I can take this one as 2.5 into, sorry, or 2.5 mega electron volt. So this is the answer. Energy in terms of mega electron volt I need to. Okay, so we'll look at next one. A cyclotron, sorry, a beam of 30 mega electron volt alpha particle is obtained from the cyclotron of radius 50 centimeter. Look at here, energy from that a cyclotron device is 30 mega electron volt. Kinetic energy of that alpha particle is 30 mega electron volt here, is obtained from the cyclotron of radius. So that alpha particle is present in a cyclotron device. It has kinetic energy 30 mega electron volt and it makes the radius of 50 centimeter here. What's the radius of the circular path? 50 centimeter. The strength of the magnetic field is required to be applied. So how much magnetic field is required in order to get this much of energy? Which thing I need to find out here? Magnetic field strength. We are having that formula, kinetic energy is equal to q square b square r square divided by 2m. I want to take out that b value here. So 2 times of m into kinetic energy divided by q square into r square, it is equal to b square r. B is equal to square root of 2 times of m into kinetic energy divided by q into r. This is the formula I got. Then B is equal to, so under root 2, mass of the charge particle is 1.6 into 10 to the power of minus 27, right? And kinetic energy, so that is 30. Look at here, 30 mega electron volt. Mega means 10 to the power of 6 electron volt. I want to convert this energy from that electron volt to joules here. How to convert that energy from that electron volt to joules? From joules to electron volt, divide by 1.6. From that electron volt to joules, I will make multiply by that 1.6 into 10 to the power of minus 19. Okay, so that energy I am converting from that electron volt to joule here. Q means 1.6 into 10 to the power of minus 19. Radius is 50 into 10 to the power of minus 2 here. Okay. Look at here, 1.6 into 1.6 under root. Here 1.6 terms will get cancel out here. 2 into 30. So that is 60. B is equal to square root of 60 into 10 to the power of minus 27 plus 6 minus 19. Minus 19 plus 6, 10 to the power of minus 13. Minus 13 minus 27, that is 10 to the power of minus 40 I can take. Divide by, in denominator, 50 into 10 to the power of minus 2. Okay. What's the value of root of 60 here? Look at here, this root of 60. So this value is in between 49 and 64. 7 into 7, that is 49. 8 into 8, that is 64. The value of 60 is in between these two numbers. So 49 and 64. So this value is less than 64. Just I will consider this value. Means square root of 60 is in between 7 point something. 7 into 7, 49. 7 point something. What's that something value here? In order to get that thing, so 7 into 2, 14 I can consider. Right. Now I will make difference of 60 and 49. So this is the trick to get that square root of 2-digit number. 60 minus of 49. So what's the value here? 11 you will get. So 11 by 14 you can make, you will get that answer here. 11 by something, so that is about 0.7. So 7.7 into 10 to the power of minus 20 divide by 50 into 10 to the power of minus 2 here. What is that answer you will get? Divide by 50 into 10 to the power of minus 2 here. Okay. Look at here. Sorry. Here 10 to the power of minus 19 term is also there. 10 to the power of minus 19 into 10 to the power of minus 19. If you divide these two terms, so you will get nearly 0.15 into 10 to the power of minus 20 plus of 21. So B is equal to 0.15 into 10. So B is equal to 1 point something Tesla. So this is the strength of the magnetic field required in order to get that 30 mega electron volt energy. So hope you are getting these things. We'll look at next one. Okay. So first you may know how to convert that energy from joules to electron volt and from that electron volt to joules. If you know these things, that calculation will be easier. Okay, next one. So similar question. A cyclotron is used to obtain 2 mega electron volt proton. Okay, so from the cyclotron I will get the energy from the cyclotron is 2 mega electron volt. If the frequency is 5 megahertz, what about the frequency? Frequency is 5 megahertz, then and potential is 20 kilovolt, then magnetic field necessary for the resonance is. Look at here. In order to get that 2 mega electron volt energy, okay, so from this one we are having the frequency 5 megahertz, 5 into 10 to the power of 6 hertz here, and potential value, so there is no use of potential value here in this question. The magnetic field necessary, which thing I need to find out here? I want to find out that magnetic field value I want to find out here. Okay, so in order to get that a magnetic field value, what is the connecting formula I can use here? Okay, so the connecting formula I can use, for example, frequency formula. So what's the value of frequency? Q into B divided by 2 pi into m here. What's the value I need to use here? So F is equal to Q into B divided by 2 pi of m here. So here B value is 2 pi m into F divided by Q. 2 into 3.142 into mass means 1.6 into 10 to the power of minus 27. Frequency is 5 into 10 to the power of 6. This is 1.6 into 10 to the power of minus 19 here. This term will getting cancel out here. Look at here. 5 into 2, that is 10. 10 into 3.142 into 10 to the power of minus 27 plus of 6, minus 21. minus 21 plus 1, so that is 10 to the power of minus 20. I can write directly 10 to the power of minus 20. Here in denominator 10 to the power of minus 19 term is there. B is equal to 3.14 into 10 to the power of minus 20 plus of 19 here. What is the value then? B is equal to 0.31 Tesla. So this is the magnetic field I require. So look at here, in this question there is no use of kinetic energy value and potential also 20 or 2 kilovolt, 20 kilovolt they given. So these are all the given things, but in order to calculate the frequency I am having this small formula QB divided by 2 pi m. Here there is no use of that frequency, here there is no use of kinetic energy and potential term here. So this is the value of magnetic field I need in order to get this much of energy.